Good afternoon, ladies and gentlemen. Welcome to Tutorials with Aubrey, where you get exclusive mathematics tutorial lessons. You can give us a WhatsApp call if you want to get in touch with us. Now, in today's lesson, I'm just giving some preliminary concepts in calculus, and basically we're going to focus on how we can convert equations from polar form to rectangular form and vice versa. All right, so that is what we are going to look at in this lesson. So let's dive in. Now for us to effectively do that, we need to understand a few things about the Argand diagram. All right, so we need to know the axes and all those points. So I gave a preliminary test. So this is the question that was in the test. You're asked to label some diagrams, and here we have mu here, which is the y-axis. Okay, just do that. So this is the y-axis. So this is the y-axis. This is omega, which is the radius. Delta is the displacement of the radius, which is also written as theta. Then we have beta, which is the x-axis. All right, so having an understanding of that, we can simply rewrite this as a triangle. I want you to imagine. Okay, so the radius is this long length right here. As you may recognize from Pythagoras as the hypotenuse, the opposite will be this side and the adjacent will be the bottom there. So now these four variables are what you're going to be dealing with whenever you're converting from rectangular to polar or polar to rectangular. So we need to create a relationship between them, and this relationship revolves around the trigonometric ratios that we know. So when we reference to this theta angle here, we see that sine theta is equals to opposite, which is this, over the hypotenuse, which is r, and cos theta is the adjacent, which is x, over the hypotenuse, which is r. What we also need to know is the r, all right? Radius, how can we connect the radius to these points? Of course, we use Pythagoras theorem. Hypotenuse squared is equals to opposite squared plus adjacent squared. So now we have these three relationships. Now all we have to do is find out how they connect to each other. So we know that using sine theta, sine theta is equals to opposite over hypotenuse. What is the opposite? Y, and the hypotenuse is r. So opposite, which is y over r. Making y the subject of a formula here, we are going to have y is equal to r sine theta. So this is a relationship we'll be using. Okay, let's take note of that. So we have 1 right here, 1, 2 right here, and finally we make use of cos. We know that cos theta is equals to adjacent, which is x, over hypotenuse, which is r. Okay, x adjacent, hypotenuse r. So now, making x the subject of a formula, we're going to have x is equal to r cos theta. Okay, and this is the third relationship we will be using. All right, let me just cut out this one right here. All right, so that's it right there. All right, so these are the three relationships we're going to be using. Usually in rectangular form, the equations are in the form of x. Okay, so in the rectangular form, your equations will have x and y. Okay, and for you to take it to polar form, you need to get rid of the x and y and make sure that it only has r and theta. Okay, so from polar to rectangular forms, you need to make sure that in the polar form it has only r and theta, and for you to move from polar to rectangular, you need to make sure that your equation has x and y. And basically what we'll be doing is we'll just be playing around with these three equations here. All right, so that's what we need to know. What we basically are going to be doing. What you should also know is that in rectangular form, coordinates are written as x, y, and in polar form, coordinates are written as r, theta. So for instance, they might give you a point, you see maybe a point, let's say 3, pi, all right? Then they are telling you to convert this point into rectangular form. It means you've been given the radius r3 and pi as the angle theta. Okay, what we should also know about theta is what we already wrote up there. So now let's look at an example, right? Let's look at an example. Let's look at an example right here. I'll just write example. All right, so convert. All right, so we're asked to convert this equation x squared plus y equals to 5 to polar form. All right, now what we said is for us to convert into polar form, there should be no x and y in our equation. It's just r and theta. So what we know is that x is equals to r cos theta and y is equals to r sine theta. So we just replace this in the equation. So where there is x here, we're putting r cos theta. So r cos theta will be r cos theta squared plus y, which is r sine theta, equals to 5. And that's it. We are in polar form, and that's basically it. All right, so we've converted to polar form like that. Okay, let's look at another example where we're converting from rectangular form to polar form. So we have this example: r cos theta equals to 3 to rectangular form. So what we know about r in rectangular form, there is no r and there is no x. There is no theta, sorry. It's just x and y. So what we know about r is that r is equals to root of x squared plus y squared. Okay, and cos theta, when we make cos theta subject, we know that x is equals to r cos theta. Making cos theta the subject of the formula, we have cos theta is equals to x over r. Okay, so meaning that in our equation here, wherever there is r, we can replace with this, okay, which has all x's, and wherever there is cos theta, we can replace with this right here. So now, replacing in our formula, we are going to have, let me just do this. So we are replacing in this formula. This is r that is squared, so we are going to square this. So we're going to have root of x squared plus y squared, and this has been squared. Okay, then here we have cos theta. Cos theta is x over r, so we say this is x over r, which is equals to 3. And remember, we don't want an r there, so we replace again the r that is here, we're going to have root of x squared plus y squared times x over r, which is root of x squared plus y squared, which is equals to 3. And we see that there are not any theta or r. So now we see that this can cancel with that. So this can cancel with one of that. So that we are going to remain with root of x squared plus y squared times x is equals to 3. When we introduce squares both sides, okay, the square here will be redistributed. We're going to have just bring this right here. Let me just bring it right here. Alright, just continue from here. When we introduce squares both sides, this will be 9 and this will be x squared. Remember, the square redistributes this time, this and that, times root of x squared plus y squared, which is just x squared plus y squared multiplied by x squared equals to 9, right? So this 2 will cancel with the half of this, which will give us that. When we distribute, this is just x to the power, this is x to the power 4 plus y squared x squared equals to 9, which is in rectangular form, and we are done. Alright, let's look at another example. Say now you're taught to convert a point like this one. Convert 2, 3 to polar form. Of course, you know this is your x and this is your y. Alright, so we know that x is equal to 2 and y is equal to 3. So now, when you are given a point like this, remember we said that in polar form the points are r, theta, and the theta should be in radians or in degrees. So basically we're sticking to our formulas. We know that r is equals to root of x squared plus y squared, and theta we know is tan inverse of y over x. If we use the alternatives where we know that x is equals to r cos theta, and we say cos theta is equals to x over r, and theta is equals to cos inverse of x over r, you're still going to get the same answers. Alright, so you can use any of these formulas. So we go on just plugging in the formulas. So when we plug the x as 2 and y as 3 in our formula for the radius, we get root of 13. And for theta, when we plug in our y and our x, we get 56.3099 degrees, of which now the point in polar form will be root of 13, 56.3099 degrees, which you can write this in radians. Okay, you can write that in radians. You know how to convert in radians. So now you're given polar and you are asked to convert to rectangular. Rectangular is x, y. You know that this will be your r, which is 4, and this is your pi, which is your theta, which is pi. So you just replace in these formulas to find your x and y, and you're done. Right.